So topic 6, which is about chemical energetic. Yesterday we discussed a chemical reaction in terms of energy can be an exothermic or it can be an endothermic. And today we'll calculate the energy change during a chemical reaction. So in a chemical reaction, what happens? The bonds will break and the bonds will form. Some of the bonds will break and some of the bonds will form. So during a chemical reaction, the bonds breaking occur. To break the bond, this change will be endothermic. And when the bonds are formed, when bonds are formed between the atoms, that change is exothermic. Example, say you have hydrogen atoms, a hydrogen molecule. So when you supply the heat energy to break the bond, so because energy is supplied or energy is taken in to break this bond, that's why whenever a bond breaking occur, whenever we want to break the bond, we have to supply energy. That's why we call bond breaking as endothermic. And what about bond forming? Like two atoms are there, they're coming closer to each other to form a bond. So when they try to come close to each other, they lose energy because the particles are moving faster. So they have to slow down to form a bond. So when these particles come closer to each other to form a bond, they release energy or energy is given out. So what we call when energy is released or given out, this change is known as exothermic. So bond breaking is endothermic, whereas bond forming is exothermic. So using this, we have to find the energy change during a chemical reaction. So calculating the energy change or enthalpy change during a chemical reaction. So the formula to calculate the energy change or enthalpy change during a chemical reaction, the formula is the bond breaking minus the bond forming is equals to the energy change or also known as enthalpy change. This is how we calculate the energy change during a chemical reaction. So formula is bond breaking minus the bond forming. Example, we have this reaction that a hydrogen molecule one hydrogen molecule react with one chlorine molecule. I'm showing the bonds as well. Sometimes they give you the equation and you have to draw the bonds. But first, because this is a beginning, so I'm showing the bonds as well. And later we will do a question in which the equation will be there. First, we have to draw the structure, showing the bonds, and then we have to complete. So hydrogen reacting with chlorine molecule, a hydrogen molecule react with chlorine molecule, and as a result, what it formed? It formed two molecules of HCl. So this is one molecule of HCl, and there is another molecule of HCl. So this is a reactant side, and this one, the right hand side, is the product side. So reactant side, what happened? The bonds will break and the product side, the bonds will, because the product is formed by formation of the bond. So the product side, the bond will form. In exam, you don't have to memorize these values. The values for the bonds will always be given to you. Like I'm just taking these numbers, random numbers, but that specific value will be given to you. Example, they say hydrogen and hydrogen, the energy of the bond is 200. Chlorine and chlorine, the energy of the bond is 150. And hydrogen and chloride, the energy of the bond is example 220. So these values will be given in exam. You don't have to memorize these values, these numbers. It will be given. So how to calculate the energy change during a chemical reaction? So first, the bond breaking side, we have hydrogen, hydrogen. So bond breaking side, we have 200. That is for hydrogen, hydrogen. Plus for chlorine, chlorine, how much energy is there for chlorine bonded with another chlorine? That is 150. So 200 plus 150, the bond breaking is 350. What about the bond forming? For one bond of hydrogen and chlorine, for a bond of H and Cl, each bond is 220. So this is 220 and this is also 220. So I can say 220 plus 220, or I can also write 220 multiplied by 2. So what is the bond forming here? 220 multiplied by 2, so that is equals to 440. Then how we can calculate the energy change during a chemical reaction, how much energy changes? So the formula to calculate energy change is the bond breaking energy minus bond forming. So what is the bond breaking energy? The bond breaking energy is 350. So we write 350 minus the bond forming energy is 440. So that is 440. So 350 minus 440, that will give us minus 90. That's right. So if we get a minus 90, if we get minus 90, a negative energy change, what is the meaning of negative energy change? This gives an idea that if the energy change during a chemical reaction, we can calculate the energy change. If the energy change is positive, it means the reaction is endothermic. And in endothermic reaction, the bond breaking energy is more than bond forming. And if it is negative, the reaction will be exothermic. And what it shows that the bond forming energy is more than bond breaking. So if the energy change, the answer is negative, it means the reaction is exothermic. And if it is positive, the reaction is endothermic. So when we calculate the energy change here, what we are getting minus 90. So what kind of reaction is this? Endothermic or exothermic? What kind of reaction is this when we are getting a negative energy change? So energy change during a chemical reaction can be positive, can be negative. If you are getting a negative answer, it means the reaction is exothermic. If you are getting a positive answer, it means the reaction is endothermic. So because we are getting a negative answer for energy change, it means this reaction will be exothermic. So you should be able to identify whether using the energy calculation that whether a reaction is endothermic or exothermic. Give another example. Say we have CH4 plus Cl gives CH3Cl plus HCl. This is a reaction and the question is, the values are given. The CH bond energy is given, example 100. ClCl bond energy is given, that is 150. And H and Cl bond energy is given, and C and Cl bond energy is also given. So HCl bond energy, how much I took? That was 220. And example C and Cl bond energy is 40. These numbers will be given. You don't have to memorize. So first what you do, you will divide this into two parts. The left hand side is a bond breaking side. The reactant side is a bond breaking side, and the product side is a bond forming. So for bond breaking, first we write how many bonds are breaking. So we have 1, 2, 3, and 4. So there are 4 CH bonds. Then there is one ClCl bond. Bond forming side, how many bonds are there? 1, 2, and 3. So there are 3 CH bonds or HC bonds. There is one Cl bond, CCl bond, and there is one HCl bond. So bond breaking side, if bonds are identical, that's why I did not write them 4 times. I just write like we have CH bonds, and how many are there? 1, 2, 3, and 4. So it is 4. Then chlorine single bond is there. CNH 1, 2, and 3. So 4 CH bonds are there. CCl bond and HCl is there. Now what we do, we write the numbers to calculate the bond breaking and bond forming. So what is the bond energy for CH? That is 100. So it will be 4 into 100 plus C and Cl bond energy, it is 150. So this is 150. So when we solve this, 4 multiplied by 100, 400 plus 150. So this will be 550. So the bond breaking energy is 550. What about bond forming? For CH, 1, 2, and 3 are there. So 1 CH is 100. So this will be 100. C and Cl, it is 40. And H and Cl, that is 220. So this will be 300 plus 40, 340 plus 220. So this will be 560. So 560. The bond breaking energy is less and bond forming energy is more. So as you can see, if the bond forming energy is more than the bond breaking, the reaction will be exothermic. And we can also calculate the energy change. Yeah, this reaction will be exothermic. And when we calculate the energy change, the formula is the bond breaking energy minus the bond forming energy. So bond breaking energy, how much the bond breaking energy was there? That is 550 minus bond forming energy, that is 560. So when we subtract, we'll get negative answer. Whenever we get a negative answer for energy change, it means the reaction is exothermic. Is it clear, this example? How we can work out the energy change during a chemical reaction? Simply by using a formula which is bond breaking minus bond forming. Another example, If I say we have hydrogen-hydrogen bond reacted with the fluorine molecule and it form hydrogen fluoride 2 molecules. The bond energies are given, the bond values are there. That is, example, hydrogen-hydrogen is 100, these are not the exact numbers. In exam there are fixed numbers. I'm just taking random values to explain the idea. Then hydrogen fluoride is example 30. So the reactant side is a bond breaking side and the product side is a bond forming side. So bond breaking minus bond forming will give us the energy change. So the bonds which we are breaking hydrogen-hydrogen bond, and we are breaking fluorine-fluorine bond. Hydrogen bond it is 100 and fluorine bond it is 50. So 100 plus 50, that is 150. The bonds which are forming, the product side is a bond forming side. So there are hydrogen fluoride bonds are there 1 and 2. So this will be 2 multiplied by hydrogen fluoride bond, that is 30. So 2 multiplied by 30, that is equals to 60. Now how to calculate the energy change during a chemical reaction? That is the bond breaking minus the bond forming give us the energy change. So bond breaking minus bond forming give us the energy change. The bond breaking is 150 minus the bond forming is only 60. So when we take a difference, it will come out as 90 or plus 90. Which reaction is this? Endothermic or exothermic? If the bond breaking energy is more and the bond forming energy is less and the energy change is positive, what kind of reaction is this? So that's right, it is an endothermic reaction. Why endothermic? Because the bond breaking is more and bond forming is less. So whenever the energy change is positive, it means the reaction is endo. If energy change is negative, it means the reaction is exothermic. Is it clear, this example? So it's a simple way to calculate the energy change. Always the bond breaking energy, which is the reactant side, minus the bond forming energy. In exam, normally the exam style question, in exam they provide you the equation. So what you have to do, what should be your first step? You should represent the equation in terms of bonds. I will give an example, like if I say we have hydrogen reacting with chlorine to form hydrogen chloride. This is how the exam they give you the question. They provide the bond energies, but they give you the equation. So hydrogen and hydrogen example bond energy is 100, chlorine and chlorine bond energy is 120, and hydrogen chloride the bond energy example 150. So you should represent equation in terms of bonds. So how to represent equation in terms of bond? Like if you remember topic 3, which is about bonding, these are all non-metals. So there will be a sharing of electron. So if I draw the structure of hydrogen, hydrogen is having one electron, hydrogen molecule I want to draw. So each hydrogen share one electron. So there will be a pair of electron between them. And when there is a pair of electron is represented by a single line. So this is how we represent a bond in hydrogen molecule, that two hydrogen atoms are bonded by a pair of electron, or we represent by a single line. Same thing for chlorine Cl2. We don't have to do this all, because before the exam you will be in good practice, so you can directly show the bonds. But right now you have to first identify the bonds. Chlorine belongs to group 7. So as it belongs to group 7, how many electron it will share? It will share 1, and unshared will be 6. So each chlorine share 1. If this chlorine share 1, the other will also share 1, and unshared will be 6 electrons. And you can see there's a pair of electron between the two chlorine atoms. So whenever there's a pair of electron, how we represent that pair? We represent that pair by a single line. So what is a bonding in chlorine molecule? It is a covalent bond, a single covalent bond between the two chlorine atoms. And what about HCl? When if it's HCl is there, so hydrogen share 1, chlorine will also share 1, and unshared on chlorine will be 6. So again the shared pair, there's a pair of electrons shared between them. So we represent by a single line. So it will be HCl. And because two molecules are there, so it will be multiplied by 2. So this is the first equation was given, and what we did, we changed the equation in terms of bond. And the reactant side is a bond breaking side. And the product side is a bond forming side. So the bonds which we are breaking hydrogen-hydrogen bond, so that is 100, plus chlorine-chlorine bond, that is 120. 100 plus 20, that will be 220. And bond forming, it will be 2 multiplied by 150, so that's equal to 300. If you want to calculate the energy change, it is bond breaking minus bond forming is equals to the energy change. So bond breaking minus bond forming give us the energy change. The bond breaking energy is 220 minus bond forming is 300. So we get minus 80. Which reaction is this? Exo or endo? The energy change is negative. So because the energy change is negative, so what it shows that this reaction is exothermic. Exothermic reaction means it will release energy. So you have to show the bonds first, and then you will calculate according to the given question. Now we'll do some questions related to the topic. This is a MCQ, multiple choice question, but we'll solve as a question. We'll ignore the answers here. Hydrogen burned exothermically in oxygen. So the equation for this reaction is there. What is the energy given out? Energy given out, energy change, basically we have to calculate. Because it's an exothermic reaction, so energy change will be equal to energy given out. Equation is given, so if the equation is given, first what we have to do, we have to show the bonds. So equation was 2H2 plus O2 gives 2H2O. We have to show the structure of hydrogen, oxygen and water. So how we can represent the structure of hydrogen, oxygen and water. First, for hydrogen, H2, hydrogen will share one electron with each other. So there is a pair of electron. When there is a pair of electron, how we represent? We represent by a single line. Oxygen is O2. Oxygen belongs to group 6. So as it belongs to group 6, how many electron it will share? It will share 2 electron. And O2 means 2 oxygen. So each oxygen will share 2 electrons with another oxygen, and unshared will be 4. So there are 2 pairs of electrons between the oxygen atoms, 2 oxygen atoms. So how we represent that? We represent by, each pair is represented by a single line. So 2 pairs are there, they are represented by the double line. And in case of water, H2O, so H2O means oxygen with 1 oxygen and 2 hydrogen. We start sharing with the least number. If hydrogen share 1, oxygen will share 1. Hydrogen share 1, oxygen will share 1. And unshared will be, but we don't have to show unshared here because we want to show the bonding only. So there is a pair of electron between the oxygen and hydrogen. So how we represent hydrogen? Then this pair is represented by a single line, and then there will be hydrogen again. So this is the structure of hydrogen molecule, oxygen molecule and water molecule. Now the question, so according to equation, it is 2H2 plus O2 gives 2H2O. So hydrogen bonded with another hydrogen, and how many are there? 2 molecules. So this is 1 molecule, then there is another molecule. Plus O2 means oxygen double bonded with oxygen. And then we have 2 water molecule. One water molecule has a structure of HOH. HOH. Then the second molecule will also have the same structure, HONH. The reactant side will be the bond breaking. And the product side is the bond forming. So when we substitute the values, each hydrogen bond is 436. So it will be 2 hydrogen are there plus 1 oxygen double bonded with oxygen. So it will be 2 into 436 plus oxygen double bond is 496. And what about the bond forming? How many OH bonds are there? 1, 2, 3 and 4. So there are 4 OH bonds. So we'll write 4 and then HO or OH. That does not make difference because OH or HO having a same meaning. So if I write HO or I write OH, that does not make difference to the final answer. So it will be 4 multiplied by 464. So when we solve the bond breaking energy, 436 times 2, that is 872 plus 498. So 498 plus 872, that gives 1370. That's a bond breaking. About bond forming, it will be 4 multiplied by 464. So it is 1856. That's a bond forming. We want to calculate the energy change. Energy change is bond breaking. The formula to calculate the energy change is a bond breaking minus the bond forming. This will give us how much energy change during a chemical reaction, or how much energy absorbed or release. Absorbed when endothermic reaction is there and release when exothermic reaction. So it is 1370 minus 1856. So 1370 minus 1856. This will give us 486. So energy change is negative 486. So C will be the right answer. Is it clear discussion that how we work out the energy change during this chemical reaction? So the equation was given. First we have to represent the equation in terms of bonds, the number of the bond, and then use the formula for bond breaking minus bond forming to calculate the energy change. Any doubt in this part? So in this question, we don't have to calculate anything. We have to just select a right answer. The energy level diagram for combustion of methane is shown. When we burn something, the reaction is exothermic. And when the reaction is exothermic, the energy change will be negative. So if energy change is negative, so either B will be answer, because it's an exothermic reaction combustion, either B can be answer or D can be answer. But when we check the states, methane is gas, oxygen is gas here. In the product, carbon dioxide is gas and water is a gas as well. So according to this equation, B will be the right answer. Why not D? Why I did not select D? Because if you check D, it is written water. L means water in a liquid. But in the reaction, the water is not in a liquid, the water is in the gaseous state. G is there. G means water in a vapor state. That's why B is the right answer. Is it clear discussion that why B is the right answer? First thing we identify, because exothermic, so it should be negative, and the states, what is written in the diagram should be same as what should be there in the equation. So in the diagram, all are gases for B, but in D, water is a liquid. That's why it is wrong. Another question. The question is, what is the energy change for this reaction? There's also a simple way you can write the number on that. So the reactant side is, this is the bond breaking side. And this is the bond forming. So bond breaking, how many bonds we are breaking? 1, 2, 3, 4, 5, 6. So 6, I'm writing here bond breaking. We are breaking 6 CH bonds. Carbon-carbon bond we are breaking. And we are breaking CCl bond. The bond forming 1, 2, 3, 4, 5. So 5 CH bonds are there. 1 CC bond is there. Carbon-carbon bond. 1 CCl bond is there. And 1 HCl bond is there. We'll substitute the values. So 6 multiplied CH bond is how much? 410. Plus CC bond is 350. Plus CLCl bond is 240. And here 5 CH bond is 410, CC bond is 350, CCl bond is 340, and HCl bond is 430. So 410 multiplied by 6 plus 350 plus 240. So the total here on the bond breaking is 3050. For bond forming, 5 multiplied by 410 plus 350 plus 340 and plus 430. So the total sum here will be 3170. Now the energy change, because in the question we want to calculate the energy change. So energy change during a chemical reaction is equals to the bond breaking energy minus the bond forming. So bond breaking energy is 3050, bond forming energy 3170. So the difference will come out as minus 120. So B will be the right answer. And what is this reaction? Exothermic or endothermic? We are getting a negative 120. What is the nature of this reaction? Exo or endo? Because we are getting a negative answer for energy change, so it means the reaction will be exothermic. Energy will be released when this reaction will occur. Is it clear, this example? Any doubt?